Final step is link the source and target using a bridge the bit set. The closed discovery instead is the process that uses the literature of source and target concept simultaneously. The connection can be an existing hypothesis, or the process can confirm the data that are available, or the process can extract a previously unknown relation. Please. This is a classical approach that has been presented by Mark Wiebe and others more than 10 years ago, but there are some tools that use also this system. The role of regulation of cytokine T1, Th1 and Th2, the differentiation, you can see that the Th1 go to interleukin 2, lymphotoxin and interferon gamma, and T-cell mediated autoimmune disease. On the other side, interferon gamma is the intermediate between Th1 and Th2. Then it's allowed to identify that interferon gamma is capable to inhibit both. Interferon gamma in some way is the intermediate element that connects the two cytokine in this kind of analysis. Please, I hope there is one bit. Now there are some tools that one can attempt to use if some of them are still working. First is PubNet, that is managed by Mark Genstein, and is using a graph-based approach. The second is BioTextQuest, that is only a system to find name entity into an abstract, and on the basis of entity, it is capable to analyze the context of this entity. The other, the more important that you can that is still working, and this system uses the previous approach of knowledge discovery, using a starting concept, an intermediate concept, and a target concept. And you can use, if it works directly, and you can test directly on your field. It's called Arrowsmith, has been developed by Swanson and Smolizer. Swanson is the professor that has developed the biomedical concept discovery using the two sets simultaneously. TextEspresso is an approach for text mining only for C. elegans. Bitola is another approach, if it's work, on literal-based discovery, finding new relation from essentially from PubMed database. There are many constraints in text mining and literal-based discovery. The first is the information exploitation. 20 years ago, in the last 20 years, the number of journals is exploited, and the number of abstracts also. Then the other is the number of databases. Today, in the January of this year, was estimated about 2,000 biological databases. 2,000. If you consider the data that in an exposome perspective, that we cannot exclude nothing except the primary database of what to do, the problem how to mine this database is really a very big data mining problem, and it's important to find something that to screen the content and to reduce the number of data sources for this thing. The second, the specialization created barrier, the knowledge fragmentation. I do not know how many computer scientists have some relation with clinician and with biotechnologies. The two languages are different. Then in order, this is the result of this high specialization is that if I am working on microRNA, for instance, I don't work on long non-coding RNA. Then my word is one word, your word is another word. Then increase to estimate what non-coding RNA do in some regulation, in general, you must merge the two words or more words, and finding the elements that are common to them. And this is another problem. A computer scientist and a logic talking data mining or fuzzy set or concept, you can see here, there are two different approaches for the same concept, for the same thing. One formalism, one other formalism. The problem is to bridge together. Thanks. Oh, sorry. Come back. They need improved tools for literature searching. As I said in the previous talk, the teaching knowledge is difficult to manage. That is the subjective knowledge. And the evaluation of concept drift. Concept drift is the uncertainty in some way. And the majority of tools are focusing on search of named entity research, not on semantic web. I think before to talking that you can find in wandering in this world is the concept of bag of word. The term indicates a certain multiplicity in one univoc that containing the word extracted from the document. If in a word there is 10 times house, the word is house. Then after transform have the count of the word, but the word is only one. In text mining, the bag of words are the data set used to perform the data transformation. Okay, I have 20 words, I make the count of these 20 words, and my vector contain is a one-dimensional vector within 20 locations, and each location contains the frequency of what normalized frequency of what you want. Their content can be affected by variation in textual information, concept drift. If I make a data set now, or on, let me say on microRNA, let's 7 microRNA, I make a data set, make my analysis, I will obtain a set of words that is in a matrix. This matrix is valid now. Because if I make the same search after 2 years, probably the matrix will be changed. This is not problem, surely, because new abstract, new information go inside, and and the topic that I am searching can be have a description. A word description a little bit different. This, please. Okay. Another term that is important, that help us to reduce the number of words, is the term anchor term. Anchor term is the intersection set between the word unique, the element of bag of word for document 1. And the element of bag of word for document 2. The intersection is the common element that that on a specific topic allows to reduce the complexity and the number and the dimensionality of the vector. Please. The other thing, come back to the lesson of Professor Basaldani, is the polarity of the concept. The polarity is defined as grammatical category associated with positive or negative meaning. We are in the hard set. 1, 0, positive, negative. In biomedical field, it's important to clearly identify the type of action. Inhibition, stimulation, increase, or some kind of term. The polarity is positive or negative according to the classical definition given by Paul Bruzza in the 1994. However, in scientific context, it's important to introduce a third class. We are going to work to the fuzzy, and the third class of meaning that is defined by other element of the context. For instance, positive and negative. The example: protein P increase the mRNA decay, enhance the transcription. Negative: chemical compound X inhibit the enzyme P. But we have neutral polarity: stimulate, modify, change, in which the meaning, positive or negative, is unknown, but depends by the context, context in which this word occur. For instance, one can say protein P stimulated the inhibition is a negative, or this drug stimulated the wound healing is a positive. Then the problem is to identify this third class. That is a big problem that require, so the identification require in which context this word is embedded. Please. Okay, I will show as an example. I think that an analysis that we have carried out some time ago. You can see the difference of the difference. These words was selected according Shannon entropy. Then instead the zip law. But in any case, give a good example about the change of knowledge during the time. You can see three queries: MAP kinases, CDK5, and beta amyloid. Because in this period we are working on Alzheimer. The aim of the project was to link some metabolic pathway to neuroscience dynamical model. The project, the proteomic, was not carried out because it's not possible in Italy to make sample from live patients. And we are switched to the text mining. You can see here that many things are agree. But in any case, for instance, here, in the case of MAPK, in the case of MAPK, here in this period emerge as relevant terms MAP and MAPK. Here emerge also MAP. This suggests that in this period some research has added new knowledge. Then in amount that allowed to emerge a new potential partner of this of MAP kinases. You can see here that the verb is clearly negative, or encode is a positive because encode a protein or other. The second case is related to the CDK5, all three proteins are related to the Alzheimer's. But in this case, we cannot find Alzheimer's are the relevant term. And you can see the dynamic of here. For instance, here you have, in the same periods, we have a CDK2. Here, instead, we have CDK4. For instance, it disappeared this protein, and it's appeared the tau. Here, there is the tau protein, and this is the, and in this case, disappeared. Then this table is only indicative about the dynamic of the knowledge that is deposited in the text. And this allows us to understand what are the dynamic of the knowledge. What is the influence on exposome? On exposome, the can be considered, instead of the time, you can consider the backward in a special region of the same, I don't know, Bhopal and